Here's a video on multiplication rules for exponents. Okay, this is what we do with exponents when our terms are being multiplied. So, for example 1, by the way, we've got 3 rules we're going to cover today. For example 1, rule 1, I will model it for you and then we'll come to a conclusion about it. So n squared, what does n squared mean? We've got n squared times n to the third power, or n cubed. So n squared means n times n. Then we've got this other times right here. Let's bring that down. And then we've got n cubed, which means n times n times n. So in all, how many powers of n are being multiplied? 1, 2, 3, 4, 5. N to the power of 5. So what could we have done with this 2 and this 3 to get us here? Exactly. So that's why we're going to call it what? The addition rule. That's what I'm going to call it. It's my nickname for what this is. Okay, let's try another one. We've got x to the power of 6 times x. Now this is a very common mistake people make. They just wanted to call it x to the power of 6 again, but that is not what it is. Let's expand it out and see. We've got x times 2, 3, 4. Let me put one here. 5, 6. 1, 2, 3, 4, 5, 6. That's what that means. Then I've got this times right here, and then I've got another x. So in all, how many powers of x are being multiplied? 1, 2, 3, 4, 5, 6, 7. 7 powers of x. So if you put your invisible power of 1 up here, once again, it is demonstrating that when we multiply same base times same base, what do we get? When we multiply same base times same base, what do we do with our exponents? We add them, okay? That is what we do. Same base times same base, we just add up our powers. We are adding powers. We're not adding bases. We're adding powers. And once again, you're going to want to make sure you keep the same base, okay? So we're going to call this the addition rule. I'm giving them silly names to help you memorize. This is not its official name. Okay, moving on. Rule number 2. Rule number 2. Let's see what happens here. We've got x squared to the third power. X squared to the third power. So you see you've got 2 exponents riding on the same base. That differs from these type of problems where we had same base with its own exponent times same base with its own exponent. This time I have 1 base and 2 exponents riding piggyback. That is why I call this the piggyback rule. And it's easy to see when you've got a piggyback situation because you'll be able to circle both exponents. Okay, you'll be able to circle them. But for now, let me show you where this rule comes from, and then after that, you'll see by yourself what you're supposed to do. Okay? So what does x squared to the third power mean? It means x squared multiplied by itself three times. Okay? And what does x squared mean? It means x times x. And what does x squared mean? It means x times x. And what does x squared mean? Remember, all this is attached by multiplication. So in all, how many powers of x am I working with? 1, 2, 3, 4, 5, 6 powers of x. X to the 6th. Now let's see, what could I have done with that 2 and that 3 to get me 6? Let's try another one. X to the third power, or x cubed, cubed. X to the third power to the third power. Once again, expanding it all out, it gets kind of ugly. We don't have to do this every time. I'm just showing you why these rules happen in case you forget how they work. So x to the third times x to the third times x to the third. Sometimes I forgot to put my times in the middle, but it doesn't matter because it's the same thing. With or without the dot, it's the same thing, but some people get confused. Okay, here we are. X times x times x. That's what x cubed means. Let's put our times in the middle. Everything's attached by multiplication here. And again, for this section, x times x times x. Once again, times X times X times X. How many total powers of X do you see? X to the 9th power. So, what could you conclude? What could I have done with this 3 and this 3 to get me a 9? So clearly the piggyback rule states that what do we do when we have a base, a single base with 2 exponents riding piggyback? What do we do with those 2 exponents? We multiply exponents. Okay? Next section. So we've got, recap, addition rule. When we have the same base times the same base, we then keep the same base and we add the exponents. So I want you to write a note up here as well that you say keep same base, add exponents. Okay? Here, you multiply your exponents together because there's only one base you're working with anyway. All right, and the very last of our exponent rules, rule 3, is, I'm not going to tell you what it's called yet. Hold on, let me just demonstrate it for you. Okay, so 4x squared, what does that mean? It means 4x times 4x. That's what that means. And so we have basically a 4 times, right here, inside here, we have a 4 times an x. And once again, everything's attached by multiplication. And a 4 times an x inside here. So we're going to multiply together what we can multiply together. Numbers get multiplied by numbers. Variables get multiplied by variables because multiplication is commutative. It's commutative means it's switchable. All right, I can switch the order of things. So that's going to be the same as if I switch the order of things, 4 times x times x. This is identical to this. All I did was rearrange stuff. So what does 4 times 4 equal? 16. What does x times x equal? X squared. And why do we know that x times x equals x squared? Because of the addition rule. Ha ha ha, look at how that works. Because of the addition rule, I know that a 1 and a 1 equal 2, okay? So now, what did we do to get from here to here? I'm not going to expand this one out. It's going to take way too long, okay? But what we basically did was, when you have a monomial, that means everything's attached by multiplication here inside these parentheses. When you have a monomial inside parentheses and an exponent outside. Now, when my exponent's inside, we don't do this. But when my exponent's outside, we share. The 4 gets the exponent. The x gets the exponent. Everybody gets a little bit of the exponent. Okay? So I like to call this rule, it's silly, but like I said, these names are silly. Sharing is caring. Look at that. Okay? Sharing is caring rule. So basically, every single digit, every single term, every single variable will get a 2 if my 2's outside. Okay? Now, let's do it with example 6. Let's just go straight into the sharing is caring with example 6. Okay? So we've got, what's my first base? -3 gets a 4. You see that the -3 is inside these parentheses? So before we square it, we're going to make sure it's just like that, inside parentheses, because we already went over the fact that parentheses do matter when we're dealing with negative numbers. Okay, is the negative outside? Is it inside? That can actually change your answer. Let's keep those straight. We're going to connect everything with dots, okay? So x gets a 4 as well. Y gets a 4 as well. And Z gets a 4. Everybody gets a 4. It's like on Oprah. You get a car. You get a car. It's excellent. Okay? Now we're going to type that in our calculator exactly as we see it. -3 in parentheses, to the 4th power will give us +81. Make sure you get +81. That means you typed it in correctly. If you're getting -81, you did not type that in there correctly. parentheses matter. Okay, so once again, the official looking sharing is caring rule looks like this. If I have two bases, A and B, inside parentheses and an exponent outside, what happens? The A gets an M, the B gets an M. Okay, sharing is caring. That is an overview of all three of our exponent rules. I hope those were easy to understand.